Lined up next, we have Bartlomiej Nowak, enrolled at the European School 1, with his project on an artificial neural network with which he generated a model of CO2 emissions and simulated different economic scenarios.
Welcome everyone, I'm Bartlomiej Nowak, and today I would like to present you my project about the use of artificial neural networks for predicting carbon dioxide emissions based on economic data. Artificial neural networks are a great tool for data analysis. They can detect trends and patterns which humans often struggle to see, helping us better understand the research problem. I've utilized these properties of a neural network to predict carbon dioxide emissions. I later use the trained model to measure the impact of specific economic metrics on carbon dioxide emissions. So let's talk a bit about these economic metrics, because data is a key part of any machine learning algorithm. It has to be accurate and relevant to the research problem. This is why I used economic data, because economic activity often involves polluting processes. So we can expect there to be a relationship between the intensity of economic activity and carbon dioxide emissions. The specific economic metrics used in the project were global coal production, global oil production, global population, global gross domestic product, total industrial production in Europe, and total driving distance in the United States of America. Unfortunately, we cannot just use the raw data sets which we download from the internet or other sources. It doesn't contain unnecessary information, which would actually decrease network performance. This is why it's necessary to clean the data. In other words, remove all of these unnecessary elements. Here we can see an example of this. On the left, we can see a raw United Nations population data set, and on the right is the simplified data set with only the necessary information left. It is much simpler, but the network should perform better at lower computational cost. It's not the final part of the data processing chapter. We also have to normalize the values, because neural networks don't perform very well with very large input values, which you might get with economic data. This is why it's necessary to scale the data to a range of 0 to 1 with the use of linear scaling. This should increase network performance. So let's talk a bit about the neural network, the brain of this project, and the structure which actually translates economic values into carbon dioxide emissions. The predictions are made in objects called neurons, which make calculations on the input value. After the data is passed through the whole neural network, so from the first layer to the last layer, the final prediction is made. Unfortunately, at first, the predictions are completely random, resulting in a very high loss. This can be seen at the start of this loss graph. And loss, in simple terms, describes how wrong the model is, how far away is the prediction from the true value. Thankfully, over time, as can be seen, the loss decreased. So the predictions were better and better over time. This is thanks to the gradient descent algorithm. The gradient descent algorithm could be thought of as going down a hill. Just in this case, the hill is the graph of the loss functions. So you're making these very small changes in the model, in the weights inside the model, to push the output value a bit closer to the real one. We repeat this process many times until we eventually reach a local or global minimum of the loss function. After a full training process, the network performed very well, as can be seen by how closely matching the predicted emissions and the real emissions are. This can be seen as a proof of the ability of a neural network to correctly analyze and interpret data, and shows the relationship between economic activity and carbon dioxide emissions. However, we can make an even deeper analysis using the model. We can measure the impact of specific economic metrics on carbon dioxide emissions. Here we can see the predicted change in emissions with a decrease and increase in oil production. Here's the same analysis for coal production. As can be seen, coal production is deemed a more significant factor for predicting carbon dioxide emissions, and generally is more influential in their value by the more drastic decrease in carbon dioxide emissions with a decrease in coal production. To conclude, I successfully applied an artificial neural network in the analysis of carbon dioxide emissions. I later used the completed model to measure the impact of specific economic metrics. This analysis deemed coal as the most influential factor. Such information can be used by governments and policymakers to make more effective policies and decisions to tackle the climate change crisis and the pollution crisis. Thank you for listening.
Thank you for joining us here. Please tell us a bit more about what motivates you to do science.
Well, I find science interesting, especially with data science, how we can use data, all the information that we have, to make a bit more informed decisions and as such more effective decisions to tackle ongoing problems.
You've been hitting two topics that are pretty trendy this year, like environmental issues, sorry about that, and AI. You're coming to those topics with a fresh eye. Like, what did you discover on your journey about like studying those things?
Well, I found which activities do have the most impact on carbon dioxide emissions in the case of my project. So it does lead to maybe more how we can change our lives also, and generally the whole society, how should it work to be a bit more friendly to the environment, which of course is, as you said, an ongoing problem.
And would you say that when you start on such a topic, on such topics, I mean, like the resources for you to advance on your project are easy to find nowadays, or is it still fresh and you need to put a lot of work to actually develop your project?
Well, if the access to data and accurate data is easy, then I think the improvements could be made quite easily, although it all depends on the statistical agencies, which, of course, I cannot influence them.
Of course.
So tell us a bit more about how you came up with this project. When did you first think of it? How did you choose artificial neural network as the modeling, as the model?
Yeah. So I generally became interested in computer science in general because of them, and I found it really interesting how a computer can interpret data in such a way to predict values which a human would very struggle. You have these frankly random numbers, and how can you relate them to carbon dioxide emissions? Like human would struggle to find this relationship, and I've just found it fascinating, really, how a computer can interpret it, and as I said in the presentation, translate it, because it is a translation, really. It's just a numerical one, not alphabetical one.
From raw data to seeing patterns.
Yeah, I just find it fascinating. Yeah. It's yeah.
Some people find that a bit scary because, like they say, it's kind of a black box, and then you put something at the entrance, you look what's coming out, and you don't know exactly what's happening in the middle. How do you see that actually, even though it's working in the end?
It's interesting. Of course, you know why, like how the model learns per se, but you don't really know why it does the thing it does. So, of course, I agree. It is a slight black box. Although I think it will have a positive impact, certainly. And so we shouldn't be scared of artificial intelligence, although we have to use it wisely.
Okay.
How often did you run the model?
Oh, so yeah, in the research phase, I would say, I tried many variations of the model structure. So it's difficult to say, but at least 10 times, 20 times, to just find which combination gives the most accurate results.
Do you have any other hobbies or passion or that are not specifically related to AI?
Oh, of course.
I'm glad to hear that.
Well, I like skiing, climbing, literature. I would say I'm a very open-minded person, open to new hobbies and passions. So, of course, science is very important to me, but it's not the only part of my life.
Okay, sounds very good.
At school, what year are you in at the moment?
So it is in the European school system. It's a S5, so the 5th year in the European school system. It's I don't have for the Luxembourgish system how it translate. So I'm now 16 years old. So.
Yeah. So it's a tiny bit too early to think about where you might want to go to university, but.
I have ideas, although not concrete decisions yet.
To do more in the area of natural sciences or in computing?
I think computing. So they can be related to natural science, but I would say the main point of the project will be computer science and the use of computers.
Thanks a lot for your time.
Thank you so much. Pleasure to be here.